Over here, I've made another chart here. So here's a routing protocol, RIP, RIP version 2, OSPF, and EIGRP. And then I've also put in here static routes and connected routes. So if you've put in a static route, and the reason I've done that is to explain administrative distance, or AD. All right. First of all, RIP has an AD of 120, RIP version 2 also 120, OSPF 110, EIGRP 90. A static route that's manually configured on the router will have a administrative distance of 1, and then a connected route will have an administrative distance of 0. Okay, and what is administrative distance? Administrative distance measures the trustworthiness of a route. Okay, so how trustworthy a route is. So let's say a router is running more than one routing protocol, or has more than one routes to a destination network. It will choose the most trustworthy route. So in this case, the best route would be the connected route. The best route would be, hey, this network is directly connected on my interface, so it's ranked 0, which that's the route that you're going to take, right? Static route has a ranking of 1. If it's been manually configured, then it's deemed very trustworthy because an administrator configured it. EIGRP has a better administrative distance than OSPF, and OSPF has a better administrative distance than RIP. So if you had more than one route in your routing table, if you had a RIP route of 120 and a OSPF of 110, then the router would choose the 110. Now, this chart of administrative distances is based on the Cisco administrative distances, I believe. So it's no wonder that EIGRP is 90, because it's Cisco protocol. All right, so administrative distance and metric. Okay, the metric is the distance to a given network. The administrative distance is the trustworthiness, right? The ranking, let's say, and then the metric is the actual distance measured. So for RIP and RIP version 2, it's hop count, and hop count is how many routers do you have to cross to get to a network, right? Is it 2 routers away, 1 router away, 3 routers away? That would be 3 hops away. Okay, OSPF uses a metric of cost, and cost is based on a number of factors, the most important factor being bandwidth. And then EIGRP, its metric is bandwidth, load, delay, reliability, and also MTU and some other things. But the most important factor in EIGRP's metric is bandwidth. So in other words, how far away something is going to be a ranking number based on bandwidth, load, delay, and reliability, the most important thing being bandwidth. So cost and bandwidth for EIGRP and OSPF is generally considered a much more advanced metric than just simply hop count. A RIP router will take the shortest path based on numbers of routers to get there, but it doesn't matter how fast the links are. In other words, if they were dial-up links running at 56K, it's going to take 2 dial-up links to get there versus 3 T1 lines to get there. So OSPF, so as a metric, cost and EIGRP's bandwidth much more advanced. Periodic updates. RIP, yes, it broadcasts its routing table using a IP broadcast address every 30 seconds. RIP version 2, yes, it does periodic updates. It sends out its entire routing table, but it multicasts it on a 224.0.0.9 address. OSPF and EIGRP do not send out periodic updates. They send out triggered updates and partial updates. Okay, so you can see here that RIP version 2 and RIP do not send out partial updates. They send out their full routing table. And triggered updates, RIP and RIP version 2 does send out triggered updates. If a network goes down, it will send it out. Then another important aspect of this is VLSM, variable length subnet mask, or classless interdomain routing. RIP cannot send a subnet mask with its out with its routing table, so it's not able to do classless routing. It has to do classful routing only. So you cannot do subnets that are non-classful. But with RIP version 2 and OSPF and EIGRP, subnet mask is included in the routing protocol, you can configure the routes with a subnet mask, so it's able to do classless interdomain routing and variable length subnet masks, so you can do fancy subnets with RIP version 2, OSPF, and EIGRP. Algorithms that they use with RIP uses the Bellman-Ford algorithm. RIP version 2 also uses the Bellman-Ford algorithm. OSPF uses the Dijkstra algorithm, or shortest path first algorithm for OSPF, and EIGRP uses the diffused update algorithm, or also called dual algorithm.